Welcome back to another video of PPS of Jai Balaya series. It's fine. So today we'll be continuing functions. As you people know, I have started functions. So functions law in functions. Today we'll be talking about inter-function communication, and very important topic, inter-function communication. Inter-function communication, and it has three types. Please make a note of it. First one is downward flow, also famously known as call by value, a very important form of inter-function communication. The second one is upward flow, okay, not that great. And the last one is bidirectional flow, extremely important, bidirectional flow, okay. And this is also known as call by reference. Please make a note of all these three. These three are extremely important, extremely important, and this will be asked in the examinations. There is no doubt about it. So I'll take these topics a bit slow, and I'll also give you the practical sorry, కఫ్ కదా, టంగ్ ట్విస్ట్ అవ్వట్లేదు, టర్న్ అవ్వట్లేదు. I'll take this topic a bit slow, okay, as well as I will show you the practical demonstration immediately after this theory part, okay. You people know now that I give theory and practical side by side. So now let's start. First one is, what is inter-function communication? See here, if assume I have a function, my first function, it may be main or any function, and I have a second function, okay. I have a second function. When I call this function add, this becomes my calling function, this becomes my called function. You people know this, right? The function which calls another function is called as calling function, okay, and a function that is been called by other function is called as called function. There is nothing big logic in this, no rocket science, common sense, you can understand this. So what happens is, when a function is called based on the parameters, based on how the parameters or the values are exchanged between each other, how the parameters or values are exchanged between each other, how the values are gonna change based on these parameters, we classify them into three categories: downward flow, upward flow, bidirectional flow. So first one, let's go with downward flow. See, I'll tell you one thing, if in case you feel my videos are fast, please reduce the video speed. If you feel that my videos are slow, please increase the video speed, okay. So in downward flow, what happens is, the calling function, that is my main function or any other function, will pass parameters. Yes, it will pass parameters. First thing, it will pass parameters. Let it is a is equal to 10, b is equal to 20. If my function is add of a comma b, a and b is passed to the add function, okay. This is first thing. Second thing, it doesn't pass the original values, it doesn't pass the original variable a and b, it passes a copy of data, it passes a copy of the data. That is, a and b here you receive is duplicates, it's just duplicate, not the original address, just a duplicate copy, okay. And second thing, remember this, whenever you call a function like this, add of a comma b, this parameter is called as actual parameter. This is called as actual parameters or original parameters. But whenever a function receives those parameters, like say this, okay, it receives something like this, these are not the actual parameters, these are called as formal parameters. Formal parameters, also known as a copy of the original parameter. This is just a copy. This is just a copy of original parameters. Second important thing, if you change the values of a and b inside this function, that is inside the add function, if you change the values of a and b, the values of the calling function, that is inside main, whatever the values of a and b were initialized, it won't change. It won't change. Remember this. If in case, for an example, let's say I have int a is equal to 10 in main, okay. After passing it in add function a comma b, after receiving it here, if I make a is equal to 20, after the end of add function, once the control comes back to the main, the value of a will not be 20, okay, it will still be 10. So any changes made in the called function won't reflect in the actual main function or a calling function. This is called as call by value. Is it clear? This is known as call by value. This is the most important line. Any changes made in the called function won't reflect in the actual function. So let's take an example for call by value. Let's write a very detailed explanation. Hash include stdio.h. Hash include stdio.h int main. Okay, now I have two variables, say int a comma b. I have set the value of a is equal to 10, b is equal to 20, right? I am printing a value, printf double quotes a is equal to %d comma b is equal to %d a comma b. Done. I am printing the value of a and b. Now I am calling a function called as set a comma b. This function will set the values for a and b. Again I am writing the printf after set, that is after calling the function set, inside main, that is my first function, inside main a is equal to %d comma b is equal to %d, close a comma b. Done. Return 0. You can copy down this, no problem. This function is absolutely correct. See here, I'm not doing anything. I have two variables a and b. I am setting the value of a is equal to 10, b is equal to 20, and I am printing it. This is my first printf in main. Okay, then I am calling the set function. After that I am printing the value of a and b after coming out of set. So what is my set function? That is void set int a comma int b. I receive the parameters passed by main. Now I am setting a is equal to 50, b is equal to 70. Okay, and printf inside set a is equal to %d comma b is equal to %d slash n a comma b, close. This is my set function. Okay, this is my set function. You can pause the video and you can take it down. Now focus. According to the condition, we are just giving a copy of the data, not the original data. And second thing, any changes made in the called function won't reflect in the calling function. So what will be the output? So the output will be, let's start from main, let's trace it. Printf a is equal to %d comma b is equal to %d. Initially a is equal to 10 comma b is equal to 20. Okay, next I am calling the set function. So let's come to set function. 10 and 20 comes here. A is set as 50, b is set as 70. So inside set a is equal to 50 comma b is equal to 70, and done of execution. We come back to here. Now we come back here, and what is the condition? Any changes made in the called parameter won't reflect in the actual calling function, right? So after set inside main, that is my program, if you can say it, inside main a is equal to 10, b is equal to 20. Okay, don't get confused. This is called as call by value. We won't send the actual person, we send a copy of the person. So our actual person won't be affected. Is it clear? Bin Laden is the example. Sorry, Bin Laden sir, don't kill me. Bin Laden is the example. He used to have a copy of his images, you know that? He used to send his replications to meetings, so that even if that person dies, Bin Laden is safe. Same concept. It's the concept of body double. That is, original person is safe, you just send another copy of the person. Okay, this is called as call by value or downward flow. That is, from the calling function the data is given to the called function, but in return nothing is going to happen to the called function. Okay, second most important one is call by reference. Okay, before understanding call by reference, I have to give you a small example or a small theory. So just listen to this. Let's assume there is a house. Okay, there is a house. So whenever we say there is a house, two things are different. First one is the person who are staying in the house. Each house will have owner name. Okay, one person will be staying in the house. In the same way, that house will have an address. The house will have an address. Whenever a new house is created, right, a person will be the owner of the house and the address of the house, both are different. In the same way, whenever you initialize a variable, okay, that variable will be initialized in the memory, right? A variable, let's say integer type 4 bytes. So it will also have two different things. First one is value that you are gonna input, that is scanf use chassis, a is equal to 40, 50, whatever it is. It's the value, and where that particular value is stored in the memory, the location where that particular thing is stored in the RAM, that location is called as address. That location is called as address. Okay, and how you assign an address to the variable, I'll tell you that. But now understand, a variable will have a value like 50 and it will have an address where that 50 is stored in the memory. Okay, now tell me now tell me if somehow I get the address of that variable, somehow I got the location where that variable data is stored, can't I manipulate it? If I manipulate that data inside that particular address, going to the exact location, that is going into this exact home and making the robbery in this house, when the owner comes back, will the house become like normal or will it be robbed? Right? It will be robbed. It will be robbed. In the same concept, if in case you fetch the address where the data is stored and you then change the data, it will be reflected in the original value. Remember that. That is, initially A was 50 was stored in the address. Okay, some other person got access to this address, he made A is equal to 40. So next time when owner comes, A will remain as 40. Just understand this thing. Okay, because he went to that address and manipulated. Here what we do, we don't pass the address, we pass the copy of the variable. That is, A will be 50. Okay, then we create another box for A, one more A or B, then we say copy this 50 and you make changes here. You make changes here. Don't touch my original house. Is it clear? In the same way, ikkada we are not sending a copy, we are directly sending the address of the variable. This is first thing. And second thing, how to access the address of a variable. For that, we have a concept called as pointers. We have the concept called as pointers. Is it okay? Pointers. What is a pointer? Pointer is a variable. Okay, pointer is a variable that points to the address of other variable. It just points to the address of other variable. Is it clear? And how to initialize a pointer is, write the data type. Let's say I have a variable A. Okay, I have a variable A and I want to create a pointer for this variable. What type of variable it is? It is an integer. So you all should also create an integer pointer. Okay, and how to say it is a pointer? You have to write star first, a star, okay, to show that yes, this is a pointer, not a variable. Then give any name you want to the pointer. That's it. But make sure that A comma star A is not allowed. You should have two different names. Okay, you should have two different names. This is how initialize a pointer. How to assign the address? For that, write B is equal to address of A. B is equal to address of A. Now what happens is, A will be pointing to its address, even B will be pointing to the same address. Any changes made by A or made by B, both will reflect in the screen. Okay, so now how to print it? Let's say A is equal to 10. I set the value of A is equal to 10. Printf, write like this: A is equal to %d, comma my pointer B is also equal to %d. And when you want to access it, you have to write A here for A, but for pointer you have to use the star symbol and write B. Okay, only place where you need not write B star is while assigning the address. After that, whenever you want to perform any operation, you have to use the star symbol. Okay, so when you do this, we will get the output as A is equal to 10 comma B is also equal to 10. We are gonna get this output. Practically, when I'll show you after this theory part, you will understand that. Okay, next thing, if I make star B is equal to 300, if I make star B is equal to 300, after that if I printf A is equal to %d, comma B is equal to %d, A comma star B. Now understand that both of them are pointing to the same address. Initially the value was 10. Now B pointer has changed it to 500. So tell me, won't the value be changed for both the variables? It's the same location, right? Yes, the value will be changed. So A will also print 300 and B pointer will also print 300. This is called as passing by reference, passing the address. Any changes made to the past parameters, actual parameters will be, any changes made to the formal parameters, formal parameters will reflect in the actual parameters. Okay, take down the example for call by reference. Main, okay, main, just main, come here, do something like this, write int a is equal to 10, let's take only one parameter, okay, and then printf value of a is equal to percentage d comma a. Done. I am printing the value of a. In the output, first I'll get value of a is equal to 10 for now. Then what I am doing is I am calling the set function again. Instead of passing a, I am passing the address of a. See here, set of address of a, just like this, I am passing the address. That's it. And again, after the function, I am printing value of a is equal to percentage d comma a. That's it. Okay, main is closed. Now write the set function, void set, and it's taking only one parameter int a, Now change, but here, see here, you can't use a, okay, because you are passing the address, so address can't be assigned to a variable, it can only be assigned to a pointer, right? Star. So you have to write int space star a. Whenever you pass the address, please remember this, you will have to use a pointer. Now set the pointer, star a is equal to 300, and just close the main, just close the set function. That's it. So when it comes here, it checks. See here, when you said int a, okay, a memory location was created and 10 was set there, okay, then you pass that particular address, this memory block address, to the function, and that was received by star a pointer. It is also pointing to the same location. Now it is changing the value into 300, so 10 will be replaced by 300 forever. Now we are gonna come out of this function. So tell me, what is the value in this box? Is it 10 or 300? It is 300. So next time when you print this line, value of a is equal to, you won't get 10, you will get 300. Is it clear? The changes made in the formal parameter will reflect in the actual parameter. This is called as call by reference. Okay, this is called as call by reference. That is the reason this is called as bidirectional flow. Because any changes made in the called function or in the calling function, both will affect the actual parameters. Okay, both will affect the actual parameters. This is the concept of call by value and call by reference, one of the most important topic. There is one more topic called as upward flow. This is not that important. In this, what happens is main function will not pass any data, but in return the called function will itself pass it some of the data. This is the reason why it's called as upward flow, because the called function is sending some data back to the calling function. Okay, I won't explain that topic because it's not important, but call by value and call by reference are the two most important topics. Okay, call by value and call by reference. So now let's see the practical demonstration of it. Okay, now let's do the practical demonstration of call by value and call by reference. Okay, let's start with call by value. Before I start, please pause this video and read whatever I told. The first point is any changes made to the formal parameters won't be reflected in the actual parameters. This is first important thing. That's only the important thing. Forget the other point. If you remember this point, you can do this. So see here, hash include stdio.h, and I'm creating a set function int a comma int b, whatever program I have explained you.
the same one I'm using here. A is equal to 100. I'm resetting the value of A is equal to 100. B is equal to 200 and printing the value printf inside set A is equal to percentage D, comma B is equal to percentage D. Just a quick demonstration, no time waste, so that my theory is, if you are clear with my theory, this is just a catwalk for you. Okay, in the int main function, here I'm creating the original variables. So I'm initially setting int A is equal to 10, comma B is equal to 10. That's it. Printf before set, before calling the set function, A is equal to percentage D, A is equal to percentage D, comma B is equal to percentage D slash n, comma A, comma B, close. Now call the set function and pass the parameters A and B. Again write the printf after set. This is after calling the set function. After set, check if the value was changed or not. Since it is call by value, I'm passing the copy of the variables. These values shouldn't be changed. And if in case it's changed, my program is wrong. Okay. Don't think that why is it not changing the color? Okay, done. And now write return 0 and done with it. See here, this is call by value. I'm passing the direct variables A and B, not the address. And I'm trying to set the value A is equal to 100, B is equal to 200 inside the set function. And after that, I'm coming out of set function and checking if the value was changed or not. F11. Okay. Now you can clearly see here, before calling the set function, A was 10 and B was also 10. And inside the set, when I called the set function, when the control went inside set function, A value was changed into 100, B value was changed into 100. After this execution, we came out of the set function and we returned back to the main. We return back to the main and see here inside main, still A is 10 and still B is 10. This is not a change. So any changes made to the formal parameters, this thing, whatever you write in after inside the set function header, this thing, any changes made to the formal parameters won't be reflected in the actual parameter. This is called as call by value. Okay. Now let's do for call for reference, call by reference. No changes. I will use the same program. Only changes, instead of passing the variable A, I am passing the address of A and the address of B. You can see here. Instead of passing A comma B, I am passing address of A and address of B. As you know, since the address is to point and pointer, we need a pointer. So I'm using star A and star B. Is it clear? Int star A comma int star B. So since it's star, whenever you're using star operator, make sure you use star like this. Okay, you have to use star. Don't think that, sir, you didn't write something like A is equal to ampersand A. See, ampersand A is here, that equals to is here. That's it. Okay, now let's change here star and star. See, in unit 3 part C, you have pointers chapter. There you will get a very good clarity about this star, about this and all. But for now, just understand the basic concept. Pointer points to the address of a variable. So I'm passing the address here. I'm passing the address here. I'm storing that address here. That's it. And I'm trying to make the changes. Now let's try running the program. No errors. Can you see here? Before calling the set function, A was 10 and B was also 10. Inside the set function, A was 100, B was 200. Even after coming out of the set function, inside the main, A is 100 and B is 200. You see this? The changes made to the formal parameters are reflected in the actual parameters. This is called as bidirectional flow, and this is called as call by reference. Okay. So if you make any changes here, that will be reflected here. And even if you make any changes here, let's say if you made changes here also, like A is equal to 20. Okay, A is equal to 20. Now run this. Now run this. See here, A became 20. That's because after coming out of set function, I changed the value of A. That is the reason A is reflected here. This means that both the set function as well as the main function, both can alter the same address location. Okay, this is called as call by reference, and this is the reason why it's called as bidirectional flow. Because if you make any changes here and call the set function, the same will be used here. If you make any changes in the set function and come out of it and return back to main, the updated values will be used here. This is a two-way communication. That is why it's called as bidirectional flow. Whereas call by value is called as upward flow, because any changes made in the set function won't affect in the main function. Okay, this completes another important topic, inter-function communication, both call by value and call by reference. Please make sure you know this, because this is a very, very, very important topic. Okay, Jai, bye. Shiva Shambhu.